Hello, everyone. My name is Isaac Sanchez. I am the Senior Partner Program Manager for Silicon Labs. In a minute, I'll go ahead and introduce our latest part, the MG24, and how we're driving machine learning with partners like Edge Impulse. I'm very excited to be here at Imagine 2022. It's my first time. I'm also very enthusiastic about the amount of machine learning enthusiasts here that are trying to grow this market space with us. So Silicon Labs, we're relatively new to machine learning. So for those who don't know us, we are a billion-dollar pure-play IoT fabless semiconductor company. We focus on wireless solutions delivered through our silicon and software platforms by offering multiple protocol solutions as well as advanced security and integrated AI ML at the edge. We're trying to drive that further. As a pure-play IoT company, Silicon Labs has spent the last decade adding key technologies to grow and enable IoT at the very edge, such as low-power MCU architectures to have longer battery life for IoT end devices. In addition, I already mentioned we support multiple protocol solutions, but we continue to drive the adoption of new protocols such as Matter and Amazon Sidewalk. Silicon Labs also foresees the necessity for securing our IoT devices from bad actors trying to breach our deployed networks. Let's see. So Silicon Labs, we're going to continue to drive the machine learning at the very edge. In that same vein, we're trying to innovate and push the boundaries even further. So AI/ML has been available on cloud platforms for quite some time, but there are a number of factors driving machine learning to the very edge. Low latency is one. So for applications requiring sub-millisecond accuracy, machine learning is a huge benefit, and it's not something you can easily achieve when you're forced to send your data up into the cloud. Another improvement is increased privacy and security. So when you're able to keep the data locally on the device, you reduce the risk of sensitive data being breached through advanced cyber attacks. More so if you consider a fleet of wireless devices sending a bunch of sensor data, of course you're going to be able to reduce the amount of bandwidth on the network, and more importantly, reduce the cost of managing that data on a server space. In some cases, you may not even be able to, you may not be allowed to have data go to the cloud, further requiring the need for machine learning at the edge. And so Silicon Labs is going to continue to grow, and in order to enable some of those benefits, Silicon Labs released the EFR32MG24 device. It is part of our Series 2 platform of devices. It is our highest performing EFR32 device in our portfolio, and it offers great RF operation while maintaining low transmit and receive currents, keeping it low power. It also has 1.5 megabytes of flash, as well as 256 kilobytes of RAM, making it great for Matter and other multi-protocol applications. So earlier I mentioned the importance of security and the IoT. So with this device, Silicon Labs became one of the first in our space to achieve a PSA 3 certification with our IoT security solution called Secure Vault. With Secure Vault, developers can go ahead and protect against hardware and RF attacks, while also ensuring that only certified devices are allowed to operate on their deployed networks. Of course, the MG24 includes a rich set of low-power peripherals that allows the connection of sensors, microphones, even low-resolution cameras. And of course, with these types of sensors, you can expand the amounts of AI/ML use cases you can perform. But more importantly, the MG24 is the first EFR32 device to include an integrated AI/ML accelerator, which is actually a multi-vector processor, or you might hear it called an MVP for short. And it performs multi-dimensional array operations such as addition and subtraction of floating point numbers on hardware, thus offloading the CPU from performing those computations in software. And when machine learning requires computations like this, and you're able to perform them on hardware, that translates to up to 8 times faster inferencing time and 6 times lower power consumption when compared to other Cortex-M devices. So here we have a benchmark of a Cortex-M and a Cortex-M with our hardware accelerator. You'll see some popular deep learning architectures listed here. And take, for instance, the example of the ResNet algorithm. With the hardware accelerator, you see that there's almost a quarter the amount of inferencing time. And this translates to lower power consumption because when you're able to spend less time in higher energy modes doing ML computations and more time in lower power sleep modes, the operational power required to perform ML is fractional. So if we talk about the quickest way to begin rapidly prototyping with the MG24, partners like Edge Impulse have integrated our dev kits into their workflow. So this means that IoT developers with traditional experience designing wireless connectivity, firmware, board layouts can now easily add machine learning as an additional feature to their IoT devices. And so what you see here is the XG24 dev kit. It has a number of sensors common to the AI/ML use cases, such as an IMU sensor, microphones, temperature, humidity sensors as well. And also listed is its predecessor, the Thunderbolt Sense 2. However, that runs on our Series 1 platform with the MG12. And while both boards are very popular, we definitely recommend the MG24 for newer designs. One, for availability with the allocation issues, and two, for the increased performance, not to mention the hardware accelerator itself. So these boards support various amounts of tutorials out of the box with Edge Impulse, as well as some machine learning workshops that I put together myself. Most recently, we've done some workshops at WorksWith 2022, which is Silicon Labs' version of Imagine, in which we discuss the current use cases for IoT. But more importantly, the AI/ML hardware accelerator has been fully integrated into Edge Impulse's firmware examples. So that means that a developer using Edge Impulse can rapidly prototype a fully optimized ML model and deploy it to a dev kit. And so let's talk a little bit about what those applications are that Silicon Labs operates in. Here I've organized a couple of application categories by the potential amount of resources required to perform one. At the bottom, you'll see a suggested amount of RAM for using our SoCs, as well as the approximate amount of computations per second to perform the ML computations for that sensor data. So if we look at the sensor example, for instance, we're talking low bandwidth time series sensor applications. For example, conveyor belts have a lot of motors wanting to monitor vibration in order to detect early failures and overall monitor the health of their assembly lines. So an IMU sensor data application like that might require around 64 kilobytes of RAM and roughly take 5 million operations per second to manage that data. Of course, with the complexity of the data increases, so does the amount of resources required. So you'll see with audio, when we get into applications like glass breakage sensors, it requires a little bit more resources. And then even more so when you get into voice recognition as well as wake word detection. I'm mostly blown away that we are at a point where we can do image processing on a Cortex-M33 device with 256 kilobytes of RAM. And we're still talking low resolution images, of course, but that also opens up the applications to do object detection and image recognition at the tiny edge. And so this posed the question to us, just how resource heavy of an application can our MG24 withstand? Well, fortunately, Edge Impulse helped us answer this question with everyone's favorite acronym, Fomo, faster objects, more objects. It's one of the more hilarious acronyms I've ever come across, so I personally like it. And that's what's depicted here. So with our XG24 dev kit, we were able to connect an ArduCam and start acquiring images of a crowded pathway and detect these people as objects. And using Edge Impulse Studio, we were able to build an ML model and deploy it to our dev kit. And with as few as 100 image samples, we were able to detect these people as objects and output image coordinates, as well as the probability that the objects detected at those coordinates are people. And we're outputting this via serial interface, as well as a Bluetooth low energy notification. So if we take a step back on what's happening here, by offloading the machine learning computations to the hardware accelerator, the MCU or the CPU is actually allowed to do quite a bit more. So if you come and check out our demo here, we will have the same thing running, but not only is it outputting these inferences via serial, it's also hosting a wireless connectivity stack. And if you see it, the actual SoC is hosting like a web service that outputs the video feed as well as the overlays of the coordinates. That's quite a bit for a cost-effective SoC as the MG24 to handle. And so if you go a bit further with that train of thought, ultimately you would be able to disconnect this from the cloud and, more importantly, save on the amount of data to manage that. You also increase the amount of privacy for capturing images of strangers in a pathway, detecting that they're people and counting them. It's not necessarily safe to have all of that data going across the network. But then there we have it. You'll be able to save on the economics of a full solution like this with a fleet of similar devices. So let's wrap up where that leaves Silicon Labs here at the Tiny Edge. We have combined machine learning with our leading wireless solutions. We are now supporting deep learning algorithms on our SoCs, and with our dev kits and third-party tools such as Edge Impulse, developers can rapidly prototype AI/ML use cases. And more importantly, with the AI/ML accelerator, when they build these models, they can push the edge. They can definitely do more to increase the complexity of the machine learning computations that they're doing, as well as optimize their tiny edge use cases to be more energy efficient. That's pretty much all I have for today, but if you guys want to know more about Silicon Labs and machine learning, you can go to scilabs.com/AI-ML. We'll also be hosting some tech talks if you want to get into the more specifics of the MG24 and see a few other demos as well. So thank you all for your time, and enjoy the rest.